Welcome. This lecture is a short introduction to deductive reasoning, and the subtitle, If Language Was Just Like Math All Along. Now, most of the time when we are endeavoring to discover truth about how the world is, we need to rely on our senses and experimentation, things like science. We need to do some sort of fact-finding in order to determine what bits of information about the world are true and what bits of information are false. And these bits of information can act as premises or evidence for other bits of information, for things that we want to have as conclusions to our arguments, right? So sometimes we go out into the world, we find out certain things, and we use those things to support certain claims that we want to argue for. And without knowing sort of the truth initially of these premises, these initial bits of information, we'd never really get to show that other claims, like our conclusions, are sound or probable or anything like that. So it is true that oftentimes we really do need to go out into the world to find anything out. And yet, sometimes we can find out whether or not an argument is a bad one or defective in some way without having to go out into the world and find out any of the real facts. Sometimes all we have to actually do is come to know about the logic of a particular argument, how the logic of an argument works. Sometimes merely by knowing how the logic of certain arguments work, we can know that the premises of the argument don't actually support their conclusion. It's kind of like, there's kind of a math analogy here. In order to know how many pieces of fruit you have, you need to go out into the world and check, right? You need to look. You need to see oh, okay, I have 2 oranges and I have 3 apples. Great. I have 5 pieces of fruit. But think about it this way. Imagine abstracting away from the fact that you have fruit. Suppose you're just wondering how many things you have. It doesn't matter what kind of things they are. Well, when we abstract away from the fruit being fruit, you've got, 2 things and 3 things. And we know what 2 plus 3 equals. We know that if someone said that, oh, you have 6 things, that they would be wrong, right? Whether or not they're thinking in terms of fruit or anything else. And knowing about the validity of logic is sort of like that. It's knowing about the sort of abstract character of argumentation, in the same way that knowing that 2 plus 3 equals 5 doesn't have anything to do with thinking about it in terms of whether or not you have 2 oranges and 3 apples or not, right? You're able to do the math even without thinking about what the 2 and the 3 actually stand for in the real world. Now, deductive arguments aim at being valid, right? Validity is what we've talked about a little bit already, when the premises guarantee the conclusion, right? Assuming that the premises are true. And now there's a number of specific ways for this to happen, depending solely on the logical relationship that holds between the premises and the conclusion. Most logical relationships between the premises and the conclusion depend on specific words that connect sentences. And that's what we're going to talk about here. So, for example, the word and. The word and has a very simple logic. When you take any 2 sentences, if you put the word and between them, the resulting sentence is only going to be true if both of the sentences are true, right? So if we take the sentence Felix is a cat and the sentence Joey is a dog, and we put the word and between them, then the sentence Felix is a cat and Joey is a dog is true only in cases where both of the simple sentences are true, right? So if Felix is a cat is true and Joey is a dog is true, then the sentence, the conjoined sentence with the and in between it, is also true. However, if either of the other sentences is false, then the conjoined sentence is also false. And now this is obviously sort of straightforward, but this is just to try out the logic of and. This logical feature is called conjunction. And now we can basically make this extremely simple argument, right? If we know that premise 1 is true, Joey is a dog and Felix is a cat, then we can conclude that Joey is a dog, right? This is very simple, very obvious, and valid argument. Remember, validity is such that if the premises are true, then the conclusion must be true. And we can see this, right? Even if the premises aren't true, suppose Felix isn't a cat because Felix is a person or something, right? Then premise 1 wouldn't be true. So in that case, we wouldn't necessarily be able to conclude the conclusion. However, if premise 1 were true, the conclusion would still follow, and that makes this a valid argument. Again, just to hit this home, we know that if the premise is true, then both of the simple sentences must be true, right? Joey is a dog and Felix is a cat. So if we assume that premise 1 is true, then we know both of the simple sentences are true because we know that the way that the logic of the word and works. And because we know that, then we know that the conclusion itself must be true, and that is ultimately the nature of validity. If the premises are true, then the conclusion must also be true. Now we can take a step further into some of the material that we're going to be talking about next week. Formalization is a process by which we can take sentences and abstract from the content of the sentences, sort of in the same way that we did with math, right? And let's stick to the simple case of conjunction just as an example. So just like the mathematical statement, 2 plus 3 equals 5, can apply to all sorts of objects. We can kind of do the same thing with language, right? Now imagine, right? So 2 plus 3 equals 5 is abstracted away from whatever you're talking about. We could have 2 oranges and 3 apples. We could have 2 cats and 3 dogs. We could have, 2 houses and 3 cars. Like, it doesn't matter what the 2 and the 3 stand for. We know that the 2 plus the 3 equals 5, right? Now we can do the same thing with language. We just have to abstract away from the specifics, the meanings, what's going on, the content of each of the sentences, the simple sentences particularly, that we're interested in. So take any simple sentence. A simple sentence is a sentence with a basic sort of object predicate structure, where you've just got some object has some property, right? So examples are things like Joey is a dog, Felix is a cat, Joe Biden is president, Donald Trump is not president, things like that, right? So simple, straightforward sentences. And we can just represent them using letters, let's say, instead of numbers, right? So the letter A means, stands for the sentence Joey is a dog. The letter B stands for the sentence Felix is a cat. The letter C stands for the sentence Joe Biden is president. Each of these sentences can be symbolized in this way. Now, sticking with this symbolization, this what we might call a scheme of formalization, where we are abstracting away from the nature of the sentences and just thinking about, these symbols now. Well, we've got a replication of our premise, our argument from earlier, right? A and B, so A, where A stands for Joey is a dog and B stands for Felix is a cat. Now here we have just a formalization of the argument that we had. And taking this all a step further, we can also symbolize the word and. We'll use the ampersand here to symbolize the word and. And now we have an even simpler argument, right? A and B, so A. Simpler in the sense that we don't have any English words in premise 1. We could get rid of the so in the conclusion. And so now basically the thought is supposed to be like, hey, we've taken language, we've taken an argument in English, and we've formalized it. We've made it abstract in the same way that you might with a mathematical statement, right? Suppose you have 3 oranges and 2 apples, and you're looking for how many pieces of fruit you have. Well, okay, 3 plus 2 equals 5, but now you can abstract from that, right? You can say, oh, okay, we've got 2 over here and 3 over here, and 2 plus 3 equals 5. Doesn't matter what they are. Same thing here. right? We've got two different sentences conjoined by conjunction and now we've abstracted away from them in a sense, right? We've associated the sentences with letters and just swapped in the letters for the sentences. Again, here, let me just continue to reiterate the notion of validity. This argument is valid because it's not possible for the premise to be true without the conclusion also being true. Even if we changed the sentences to false ones, right? Even if we changed, like, you know, Joey is a dog to Joey is a person. Joey isn't a person, he's my dog. In that case, you know, A and B would be false. So this argument wouldn't be sound, but the argument could still be valid. Why? Because if the premise was true, assuming it's true, then the conclusion would follow, right? Anytime you've got these sentences, right, A and B, if you've got a sentence of that form where the logic, you know, we're just worried about the logic of and the only thing that can happen, right, if sentence 1 is going to be true, is that both sentence A and sentence B have to be true. So A has to follow for this to be valid. And this is just an assumption that we're making, right? It's the same kind of thing, right? Suppose, you know, like in a mathematical example, right, you've got 2 oranges and 3 apples, and that makes 5 pieces of fruit. If you swap out your 2 oranges for 1 banana, right, well, now you don't have 5 pieces of fruit, sure, but that doesn't make it a different, you know, that doesn't make it different that 2 plus 2 doesn't equal 5, right? It's not like, oh, all of a sudden 2 plus 2 doesn't equal 5. No, you've now changed the actual facts of the matter, right? All of a sudden you've swapped 1 banana in for 2 oranges, and now you've got 4 pieces of fruit because it's 1 plus 3, right? But that's not the point here, right? The point here is even if the facts are different, right? Even if you've changed the specifics, now you have 1 banana instead of 2 oranges. That doesn't mean that 2 plus 3 doesn't equal 5 still, right? 2 plus 3 is still going to equal 5, kind of no matter what, because that's just how plus works. The same thing kind of goes here when we're talking about validity. The way that the argument is structured is going to guarantee in a certain way that the conclusion is true on the assumption that the premises are true. So now, besides using the ampersand to stand for and, we're going to, in the future, be using these other logical connectives, and we're going to be using these symbols for these connectives. And we'll talk about these in more detail as the class continues. But each of these phrases, each of these terms, ultimately has its own kind of logic. The word not, or what we call negation, is symbolized by a little tilde. It's a little squiggly line. And the tilde attaches to sentence letters in this way, right? You stick it out in front. So not a is what that sentence says. And or conjunction, right? We symbolize using the ampersand, and we put the ampersand in between 2 different sentences, right? A and B. The sentence or the word or is also logically important, and we symbolize that using V. A or B is the way that you say that symbolized statement. And finally, the phrase only if. This is also interchangeable with the phrase if then in sentences of the form if blah, 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 then blah, 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 right? You can actually do it both ways, and we'll talk about that more as well. And that symbol in different logic books use different things. Sometimes they use arrows. Sometimes they use what's called a horseshoe, which is like a backwards letter C. In this class, we're going to be using just sort of V on its side, or it's sort of a bracket, like a greater than or less than symbol. This is the greater than symbol. And you can kind of think about it more as like an arrow, right? It's pointing from the left to the right. And basically the way that this sentence goes is A only if B is the way that that is stated. And each of these has their own logic. But yeah, so we're just going to use this symbol mostly because it's easier to type. If you had to handwrite all of this, we could use the symbol that all the other logic textbooks use. But in this case, it's just easier to type this little arrow, greater than arrow thing. So we're going to use that for the rest of the class. So now each of these logical connectives are going to attach to sentences, right? They're all going to go in between two sentences, except for negation, the not sign. The not sign always goes out front of a sentence. And to formalize, ultimately, sentences of English, right, or arguments in English, what we're going to do now is take all of the simple sentences and convert them into sentence letters, and then take all of the logical phrases, all of the words and, or, only if, or not, and change them into the corresponding symbol. So we'll have simple sentences without any sort of, are going to be sentences without any logical connectives, any logical words in them. We're going to change those to letters, and then we're going to change all of the logical symbols to, or all the logical words to logical symbols. And that's ultimately how we're going to formalize our language, and then we're going to use that to make arguments. Here's some simple examples. Take the sentence, we've got C, Joe Biden is president, and D, Donald Trump is president. Now we can negate the first one, right? Donald Trump is not president. Well, how are we going to symbolize that? Well, we take the simple sentence, Donald Trump is president, and we put the negation in front of it. Now, not D expresses the sentence, Donald Trump is not president. Or maybe another way of putting it is not the case that Donald Trump is president. Disjunction, where we've got the or, right? We can take the sentence, the two sentences, and put them on either side. Either Joe Biden is president or Donald Trump is president. And that's going to be symbolized basically just with the wedge, right? C or D. And then conditional, or the phrase only if, right? We can symbolize in this way, right? We take the sentence, Joe Biden is president only if Donald Trump is not president. Well, now we've got two sentences, and actually two of them are complex, right? With the whole thing, we've got Joe Biden is president only if, right? There's the logical word, and we've got Donald Trump is not president, the word not there being another logical word. And so how are we going to symbolize this? Well, we're going to use the little arrow director, and so we've got C arrow, not D, right? And that basically what that says is Joe Biden is the president only if Donald Trump is not the president. It's worth focusing on this last sentence a little bit more. Joe Biden is president only if Donald Trump is not president, right? The formalization C only if D, right? C arrow D here would not, it would be incorrect. It wouldn't be the correct translation. Because Donald Trump is not president contains the word not. We have to be careful and cognizant of all of the logical words that matter, and the word not is going to matter, as we'll come to see. Also recognize that putting the negation out in front of the whole sentence would not be correct, right? Because this wouldn't be the right place to put the word not. If the whole sentence said it's not the case that Joe Biden is president only if Donald Trump is president, then that would make sense, but that's not what it says. We're going to be returning to this to explain what's called levels of scope later. Now that we've gotten a little sort of primer on formalization, you can see what it's good for. And this is kind of the point of going through all of this, is that the formalization of deductive arguments basically helps us to find valid argument forms. Valid argument forms, basically simple arguments that are valid all the time. In the same way that 2 plus 3 is always going to equal 5, certain arguments that have certain forms are just always going to be valid. That means that they're always going to be such that if the premises are true, then the conclusion must also be true. And that's what we're looking for. If we can find valid arguments, then we have good reason for thinking that the arguments are good, and then we can check the premises to see whether or not the arguments are sound. So here's a really simple argument form that's valid, right? Take this argument, either Felix is a cat or a dog. Felix is not a dog, so Felix is a cat. Now, what exactly do we have here? Well, we've got two sentences, sentence A and sentence B. Felix is a cat and Felix is a dog. And premise 1 can be formalized as A or B, right? Either Felix is a cat or Felix is a dog. Premise 2 says that Felix is not a dog. Well, we can formalize that by taking B and adding the negation sign in front of it, right? So we've got premise 1, A or B, premise 2, not B. And by the way that the logic of or and negation works when they're kind of combined in this way in an argument, well, we know that if premise 1 is true and premise 2 is true, right? So we know it's true that either Felix is a cat or a dog, and we know it's true that Felix is not a dog. Well, then it's just going to follow, because we know that premise 1 is true here, and we know so either one of the disjuncts, right, either A or B has got to be true, because that's the only way that a statement of the form A or B could possibly be true. So now we know that A must be true. It must be the case that Felix is a cat. Here is another simple, valid argument form. If Joe Biden is not president, then Donald Trump is president. Premise 1. Premise 2, Donald Trump is not president. Conclusion, so Joe Biden is president. Now what we can do here is we can formalize this. So first we'll take Joe Biden as president as J. If you notice there, the word not has not been included there. And we'll take the letter D to stand for Donald Trump as president, similar to what we did earlier. And now the argument as formalized, right? If Joe Biden is not president, so not J, then Donald Trump is president, right? So we've got the, if it's the case that not J, then we've got the arrow and then D, right? If it's not the case that Joe Biden is president, then Donald Trump is president, right? That seems like that's probably what would have happened if Joe Biden hadn't gotten enough votes. Premise 2, it's not the case that Donald Trump is president. So Joe Biden is president. Now this is actually a little bit of a complicated argument form. It's a valid argument form that is called modus tollens, and we'll talk about that next week. But it works basically on the way that the conditional sentence works, the logic of the conditional, the if-then sentence in premise 1, and the logic of negation. Well, as it happens, if you have the negation of the second half of a conditional sentence, then what's going to happen is the negation of the first half of the conditional sentence will follow. And when you've got that, if you are following me now, what that means is that you would have the negation of the sentence Joe Biden is not president, and then that would be a double negation, right? So it's not the case that Joe Biden is not president would ultimately result in Joe Biden is president. If you didn't follow that, don't worry too much yet. Just, try to rewind and see if you can get it. But next week, we're going to be going over this stuff in more painstaking detail. Next week, we're going to be focusing on deductive logic and deductive argument forms. So from this, I hope that you take at least a primer on how we're going to be formalizing these sentences. And there will be a chapter for you to read, or sections of a chapter for you to read from an actual logic textbook that will cover some of the argument forms and some of the ways that we're going to be operating next week. We're going to talk a lot about the way that conditional sentences work, and we're going to talk about some formal fallacies.